This is a follow-up video to my SFIC picking analysis. We're looking at a Master Keyed SFIC, or small format interchangeable core. The question is a Master Keyed SFIC easier to pick? Well, I think we all know, of course it is. So let's take a look why. This is a World War II best padlock. You can tell it's World War II because it's not brass. It's made out of cast zinc or some other kind of material, because brass was in a short supply during World War II. And it's a 6-pin key, or 6-pin core. Here's the original key. And I had a heck of a time picking this lock to control. That's what I wanted, to get the core out so we could look at the pins. Okay, here are the original pins. I got the core out of the padlock using the lab annex, which you could review in my previous video on SFIC picking analysis if you want to see how that was done. So here they are. These are the original pins that came out of that lock when I was able to pick it to control. So I want you to notice these are the key pins. They're labeled A. My friend of mine, Josh, labeled all these key pins and all the operating pins according to the actual specification. If you measure the length, that's the numbers that they are. So these were the key pins. Above that, we have master pins. Notice we have a master pin in every single chamber. That means this is a fully master keyed lock. And above that, these are pins that we call control pins. These would determine the control shear line. According to how the bitting is the key would lift the all the pin stack to the various shear lines. These are just called top pins. They're to force everything down, and the springs would be on top of that, which I'm not showing here because we're not interested in that at the moment. Okay, here I've taken the liberty of replacing all those old worn out pins with brand new pins. The main focus was so that you could see the nickel silver pins, or key pins. See, they're a different color. Those are the key pins. So we got a 2, 1, 4, 1, 2, and a 5. And above that we have the same identical pin stacks in brand new lab pins. So let's take a look where the shear lines are, and that'll make things move along. Okay, now we have the operating and the control shear line. It's a number 10 distance between the two shear lines. So here's the operating shear line. Notice we're all set here at an operating shear line, and here's a control shear line. Wait a minute, we have a chamber here on a control shear line, and here we also have a chamber on the control shear line. Notice I've marked those here. So a number 4 key cut would lift the pins in chambers number 3 to both operating and control shear line at the same time, which also occurs here in chamber number 5. And number 2 key cut gets both the operating and the control shear line. Notice that this distance here, 4 plus 6 equals 10. Well, that just so happens to be this same distance between the control and the operating shear line. Same thing in this chamber. A 6 plus 4 equals 10. So we've hit both the operating control shear line at the same time. And now this really only occurs on this very specific lock, but in many cases you may have, with a master pin lock, you may have several cases where the control and the operating shear line are the same, and it could be even with no master pins, but that wouldn't generally be the case. So here in this case, we've gotten both the, we're still looking at the operating and control shear line, but notice now in chamber number 6 with the 7 key pin lift, I have used this number 2 master pin and this number 10 control pin, which actually also makes this one both at operating and control at the same time. So I've left these other chambers the same, except for number 1 here. I added this number 4 master pin just to show you a little variety of what's going on in lifting these key pins. So next I'm going to show you a little slide stop action of lifting these pins and these pins up and down and see what happens. So I hope you enjoyed that stop action. Here is that same slide. I just stopped it here. I wanted you to see that to get to the control shear line here in chamber number 1, I still have to lift it a little bit higher to get to this shear line here. Here in chamber 2, I've gone way past the control shear line. I'm still at an operating shear line. You know, I'm operating this operating shear line. You know, the lock will open. But I'm way past control here in this chamber number 3. Yeah, I'm both at operating and control at the same time. In this chamber number 4, I've done a 1 lift. I really lifted this thing to the maximum, and I've passed the control shear line, but I do have an open here in chamber 5. Wow, a number 2 key pin lift lifted both, got me to both operating and shear. Here in chamber 7, we saw this. You have to add this number 2 key pin to give me this 10 control pin, so I got that at both operating and shear at the same time. So here's another possible key bitting that would, or another key pick that could get us to operating. See, I've lifted number 6 here. Now I've used the master pin. We've seen that, but here's a different one. 1 plus 4 gives me 5. That's a 5 key pin, or 5 key bitting, excuse me. And that puts us on an operating shear line here, just lifting the key pin to number 4. Here, I've got a 1 plus 8 gives me a 9. That's the key cut. I need a number 9 to get me to operating. Here I've got a 2, and this, again, as both the control and the operating shear line at the same time. Here, I dropped away the master pin, but still I just need a number 5 key lift in chamber 6 to get me to that operating shear line. So here the lock would open. Now here's yet another possible operating configuration where I've lifted everything above each master pin. So this takes a 6, 5, 8, 9, 8, 7 would be the key cuts to open this lock to operating. And notice in chamber 7, when we have the 5 plus the 2, we've got a 7, and with the number 10 control pin in there, that gives us both the control and operating shear line at the same time. This was just really another slide to show you there's many possible ways to reach an operating shear line. But then how many ways are there to reach a control shear line? We'll take a look at that next. Okay, now we're at control shear line here. So we now have picked this lock to control. Let's look at the key lifts that it required. A number 4, a number 9 in chamber 2. This is a very shallow lift. I've barely lifted the key or the pin stack. Here, number 2 lift in chamber 5, I've lifted it a whole lot. Here in chamber 6, which is at the very front of the lock, notice I've only lifted it to this first shear line here, and this is also an operating shear line. If I kept lifting it to a number 5 lift, I'd click past this master pin and I would be at operating right here, but I would have passed control. So this particular chamber takes 1, 2 clicks to get to control. Look over here. Here's control, and I'm at a 2 lift, which is really quite a high lift. If I was at this shear line here, this would be 2 plus 6 would be a number 8. That's barely lifting it up. But I lifted it really high to get to control. If you look at chamber number 4, I've got already passed it up. This was a 9. 8 plus 1 is a 9, so that's barely lifting it. I lifted it up more. I got to control here. Over here, this is another chamber where I've hit control and operating at the same time. But I've lifted it up considerable amount. This 4 plus 4 here would have been an 8. So if If I lifted it to an 8 to the first click, then I would have just got an operating shear line along here, but I lifted it to a 4, which also put me at control. So this was kind of deceptive because there were 2 clicks here, and then we're both at control and operating at the same time. Now this is a very interesting chamber, because here, when I started, this is just a very small lift. I just raised the pin stack just a very little, and I've hit control shear line first. I have not lifted far enough to hit number 5, which should be this 1 plus 4, well, that would be a 5, or even lift it higher all the way to a 1, which is just hardly any key cut at all on the key cut, but it really lifts the pin stack really high to a 1. I mean, I'm way past control. So this one really faked me out badly because I kept overlifting this stack. When I realized and I stopped, when I felt this first click on number 9, which was barely lifting it, I decided to stop there. And that turned out to be a control shear line. So if I had kept lifting past that and looked for more clicks, I never would have got a pick to control. Over here, see, we have, we're still below this operating shear line, so we've clicked there. We haven't got to a number 2 lift yet, so we passed the number 6 lift. Excuse me, we haven't gone to number 6, we've gone to 4. Well, we've passed the number 6 lift, and we've gone to a 4, which has put us here. We could keep lifting even higher and go to a number 2. So this whole thing is a big mess. But there's only one control shear line, which is literally what I wanted to get to, and there are many operating shear lines. This is kind of a lucky case where you hit the control shear line first. These both the same, but you still have to get there. This is both the same, this is a 10 distance, this is a 10 distance, and this is this one here's a 10 distance to get to control. So in these 3 chambers, yeah, we've hit control and operating at the same time, but you don't really realize that. I think it was fairly obvious to me over here because I could detect this little 2 key pin. I was either getting a click on 5 or a click on 7. So if I left it on 7 and didn't try to lift it any higher, that was successful. And this one really threw me because I had to lift it. This was my first click, just barely lift it, and then I'm on the control shear line. So it's just kind of a crazy scrambled up mess. These are like really 2 independent locks, 2 different shear lines, but they interact with each other. So in closing, yeah, Master Keyed small format interchangeable core is easier to pick operating, but it's much more difficult to get to control. That was kind of the whole lesson I got here, and there was really no relation madness between the 2. You just keep getting operating. You have to really kind of realize where your pins are set, kind of memorize what's lifting where, and just keep working at it, and you'll get it. Now, I just wanted to show you here that I had actually created a control key, obviously because I knew the bitting. Here's the control key with a C, but the main point I wanted to make, and this was another operating key I made just for the heck of it. You can see the bitting is quite a bit different. But the whole point of this is that there are up to 64 possible operating keys. So there's 64 shear lines. There's 2 for each position. There's 2 here, 2 there because of the master pins. So 2 times 2 times 2 times 2 times 2, or 2 to the 6, gives you 64. So there's 64 possible operating shear lines. So you can be picking on this thing and you just get operating after operating. But the key is to memorize and know where those operating positions are, and you kind of eliminate those, and you eventually get to control. That's apparently the only way you have to do it. So thanks. So thanks for watching. There's the original key. That's the only key I ever had, and obviously I've got a control. Hope you enjoyed that, and I will also post a a little video on picking with a special pinning for a fake pinning. I hope you should check that one out. It's only a couple minutes long.